Continuation of the previous lecture, test for convergence of series of positive terms. It will not be always possible to find the nature of an infinite series as we have solved in the earlier examples. We have to employ various tests which are established from the basic definition of convergence and divergence of an infinite series. Here we are going to discuss two tests for infinite series of positive terms. The first test is Cauchy's root test and the second one is D'Alembert's ratio test. First we look into the Cauchy's root test. If summation un is a series of positive terms and if limit n tends to infinity of un whole to the power 1 by n, which is equal to L. L means a finite quantity. Then the series is convergent if L is less than 1. When L is less than 1, then the summation un is said to be convergent. If L is greater than 1, then the summation un is going to be divergent. If L is equal to 1, then the summation un is going to fail or the test fails. Please take a note here. This method is useful if un is of the form f of n whole to the power g of n. And some of the standard limits or the properties of the limits we are using here. The first one, limit n tends to infinity n whole to the power 1 by n, which is going to be 1. The second one, limit n tends to infinity of 1 plus 1 by n whole to the power n, which is equal to e. The value of e, which is approximately equal to 2.7. And the third one, limit n tends to infinity of 1 plus x by n whole to the power n, which is equal to e to the power x. Now we look into the some of the examples on the Cauchy's root test. The first example, test the convergence of summation n is equal to 1 to infinity a n square x n where a is less than 1. Here, by the data, whatever after summation we are observing, we have to write it as un. Therefore, un is equal to a n square into x to the power n. Now, for the un, I have to, according to the definition, I have to find, therefore, un to the power 1 by n. Now, un, after writing the un to the power 1 by n, which is equal to un and to the power 1 by n. Please simplify it. I am going to get the answer an into x. After getting un of un to the power 1 by n, you have to apply the limit by the definition. That is, limit n tends to infinity of un whole to the power 1 by n, which is equal to limit n tends to infinity an x, where n is tending towards infinity. Then the answer will become 0. 0 is less than 1. Therefore, the given series, that is summation un, we can say it as is convergent. Now we look into the second example, that is summation n is equal to 1 to infinity of 1 plus 1 by n whole to the power n square. The given thing after the summation will consider as un, and you have to write un to the power 1 by n. Un, then 1 by n. Simplify it. I am going to get the answer 1 plus 1 by n whole to the power n. Now apply the limit for the both the sides. When I apply the limit, it is in the form of the standard form. Therefore, that is by the properties I have given, this is going to be equal to e, where e is approximately equal to 2.7, then 2.7 is greater than 1, then the given series is divergent. Third example, summation log n to the power minus 2n. This is equal to un. Now you have to solve it by the definition, that is limit n tends to infinity un whole to the power 1 by n, limit n tends to infinity log n minus 2n 1 by n. Simplify 10 and will get cancel log n to the power minus 2, where n is tending towards infinity means which is equal to 0. Then 0 is less than 1. Then we can say that the given series is convergent. Fourth example, summation n is equal to 1 to infinity of 1 plus 1 by root n whole to the power minus n to the power 3 by 2. This is your un. Next you have to write un whole to the power 1 by n, un whole to the power 1 by n. Simplify it. You are going to get un whole to the power 1 by n, which is equal to 1 plus 1 by root n whole to the power minus n 1 by 2. This can be written as 1 plus 1 by root n whole to the power minus root n. Apply the limit on the both the sides. After applying the limit, this I can write it in the form of 1 divided by 1 plus 1 by root n whole to the power root n. Now this is the standard form of the limit. Therefore, by the property of the limit, I can substitute it as 1 divided by e, that is which is less than 1. Therefore, the series is going to be a convergent. Next example, summation n is equal to 1 to infinity of n plus 1 whole to the power n into x to the power n divided by n into n plus 1. Here this is your un. Now write un to the power 1 by n, un to the power 1 by n. Simplify it. We are going to get the answer n plus 1 into x divided by n to the power 1 plus 1 by n. Now apply the limit for this. That is limit n tends to infinity un whole to the power 1 by n, which is equal to limit n tends to infinity and this value. After applying the limit and where n is tending towards infinity, here if I take out the n common, that is n out, we remain with 1 plus 1 by n. Therefore down the denominator n into n to the power 1 by n. N and n will get cancelled. We remain with 1 plus 1 by n divided by n to the power 1 by n. When n is tending towards infinity, we remain with 1 plus 0 of x divided by 1, which is equal to x. Therefore, here we got the answer as x. I don't know what is the value of x. Therefore, I can say that this summation un is convergent if x is less than 1 and if it is divergent if x is greater than 1. Based on the x value, the series is going to be convergent or divergent. The last example, that is summation n is equal to 1 to infinity of n plus 1 divided by n to the power n square into 1 by 3n. Now this is your un and apply the limit, that is limit n tends to infinity un of 1 by n, which is equal to limit n tends to infinity your un to the power 1 by n. Simplify it, take out the simplify it, you will get limit n tends to infinity 1 plus 1 by n. This square is there, 1 n will get cancelled, only 1 n will be remaining and n will get cancelled. We divided by only 3 is remaining here. This is the property, that is which is equal to e by 2. There e by 3, denominator is 3, therefore which is equal to e is equal to 2.7 divided by 3, which is less than 1. Then the series is convergent. The given series, that is summation un, is convergent.